Okay, so classes. Let's look at, these are some of the keywords that we're going to see today: class, constructor, super, and extends. But first, let's review why we want constructor functions why we want to use constructor functions in our programs. Um, so here's an example where, let's imagine in our application we have, let's say we're building a social media app, right? So we're going to have, or basically any app that has users in it. It could even be Canvas or an application that keeps track of payroll for a company. You might have as many user objects as employees in that company, right? So one way in which we could do that we just create a different object for every employee, right? So in this case, we have user 1, name N, user ID, user 2, user 3, right? We have in this application, we have just 3 users. But let's see, these users are made individually, right? They are what we call object literals. We made them by using the curly brackets and defining their names manually. Let's see what some of the pitfalls of doing that will be. Let's say we're creating a new, once let's imagine we get a new employee, right? So if we get a new employee, then we have to update our software company to be able to include that new employee. And that will be like going in the code of our software and adding a new user 4. Right? One is that will be boring, right? Having to go in and change your program every time you hire someone, and it will be time consuming, and that's just simply not the way that we do it in real life. But also in doing that, we could do something like in this case, which is because we're doing all these manually, we could misspell user ID here, where we had the kind of standard before that all of them were going to be user ID camel case with the I capital. Let's say we're adding a new one and we forgot that was like a standard we were supposed to use, and now we create one with I and D capitalized. Right? So now our boss comes in and then he tells us to generate a report with all the IDs of all of the employees. And because we know array methods, then we say, oh, I could do that with a map. Right? I could loop over an array with all the users and get, again, as map is a loop, and we pass in a callback function to our map. That callback will visit every single user. And in here, what that callback is doing is just returning the user ID of the user object, right? So in this could be a report that, yeah, again, our manager, supervisor, or even ourselves as owners of a company could want, having all the IDs to maybe check all the information that we have somewhere else. And in this case, because we have one object that doesn't conform to the standard, right? We have this user ID. This was the standard we were following. Now we have one user that a developer just typed the wrong key or left the caps on. Now once we try to generate that report, we have this undefined here, right? Because if we think about it, well, user 4 doesn't truly have a user ID. It has another key that is user capital ID, right? And then that will give us undefined here. Any questions here so far? Cool. So this is again why we want to avoid this and how we can avoid it. For that, we saw yesterday we have constructor functions. There is just a blueprint, a template for an object. So a better way to approach this would be having a constructor function called user. That constructor function is expecting 2 arguments, name and user ID. and it's just going to assign that name and that user ID to this object with the same keys, name and user ID. Right? Now, then, instead of creating all these objects manually, we could just have invoke the constructor function, or call it, passing in the name of every employee and their ID, right? That's the two things that we want. And then we store the result of calling that constructor function into a variable user1. Here what we're doing is this is known as creating an instance. User1 is an instance of the user constructor function, right? Or we could say that, well, user1 is a user because it was made with the user constructor function. And then we will do that for the 3 of them, or in this case, the 4. And that will ensure, because we use the same template, we use the same cutout for all of them, that all of them will share the same properties, which is name and user ID. Or not share, that all of them will have their own name and user ID properties. And we reduce the possibility of a mistake and a typo, for instance. Any questions here so far? We can see that, like, now if we try to generate the same report, well, in this case, because user 4, user 3, user 2, and 1 have the same structure, they were made out of the same template, the same blueprint. Now user ID is not misspelled, and we get what we actually want, which is all the IDs. Yes, Cameron?
Is there a way to talk about everybody at once by...
Say that again?
Is there a way to talk about everybody at once?
You mean here? Inside the callback to the map? Or what function are you talking about?
No, like you make like say like instead of like doing a constructor function, you know how to show everybody in the right.
I think I'm not understanding the question. You mean like if I have a console log inside the constructor function, like here?
I just like say I have like 10 people, and I want to display them all because they're in construction. How do I display them all at once?
I see, but well, not all of them are in the constructor function. If that's something that I think I heard you saying here, constructor function is just a template for what a user looks like.
Right. So you can't call that.
I cannot. Yes.
So where are they? They're in memory or something? Like where are they?
In that case, what I could have is just an array, like here, an array of all the users, and then in that way. Yeah. Yes. Or I could have. Here's another idea will be, okay, so since we're writing programs and we have seen and we have talked about here of object-oriented programming, right? And what that means is, one more time, is just kind of modeling the real world in a programming language, in a programming environment, in a computer environment, right? The computer doesn't know what a user is, but in this way, we could sort of express the idea of a user, right? So what we could do is we could have another constructor function that is, let's say, department. And users or employees belong to a department, right? So we could have that department keep track of all the users. And then we could have something that prints all the users in department, in HR, for instance. Does that sort of rings a bell? As to like, if we want to keep track of all the users, then we could have, in this case, we just have an array. But if we think a bit bigger, we could have another constructor function that represents a department within a company, and that constructor function will be in charge of keeping track of the employees.
So, one last question. We have 300 employees, what are we saying?
If we have 300? What do you mean by our code being insane?
Yes.
Mm-hmm.
100. We do it 100 times.
Oh, okay. So I guess what you're trying to say is like we're still kind of repeating ourselves in here. Like we reduce the repetition a little bit, but not entirely. Is that correct? Like here we were creating 3 objects manually, and here we're creating still 4 objects with just the help of the user method, right? The thing is now, because we have a function, and what's the goal for functions? What's the reason for existing mostly? Say that again. Organize. Yes, I will say that's like a secondary reason, but what's like one of the primary? Oh, reusability. That's like the main point. Reusability in functions. That's why we want in functions be able to reuse them. Yes, Hugo.
From my question was asking, couldn't you like have like an array of like users and then
Right. So let's see, to connect what Hubel said, like have an array and then loop over the array and then create a user for each one. That could be a plausible scenario. Let's imagine you get a huge file where you have the name of the person and the ID, and then in the next line, the next of the name of the next person and the ID. And this could be a file that you get to. Let's say I want to add all these people to my organization, right? So what you could have is now you know that you have the name of the person and the ID. So what you could do is, let's imagine this. Let's say you have the name of the person like Anne and the ID. And then you have in the new line Ben and the ID. It could be separated by commas, or it doesn't have to be. Let's do 0. But let's say you have this file, and imagine you have more. Imagine you have the 300 that Cameron said. What you could do is because this file, we could read this file as just a string, right? So if we look at this file just like a string, imagine this is just a giant string that has 2 new lines. One new line here, and then it has names are separated by comma. What we could do is we could, using the tools that we already know, like split, to convert a string into an array. What we could do is basically generate an array out of this file. And with that, then we could, as Hubel said, let's imagine we have, instead of this, then we'll have an array that looks like, let's do this. So we have an array of strings now. And then we know that each string, where did my file go? Represents the user, right? This is still not a user object. That's what we want. We want this data to be in a user object. But now we have it in an array. So what we could do is loop over this array, and for each element in the array, in this case we have 2, create a new user object with this information. Let's say, I'm not sure if, I don't think we can go onto that example. But what I'm saying is, if you hire a new person, you don't want to just have to go on your code and say user 5 equal new user Alejo and whatever ID. You will have something like whatever you're keeping your users. It could be an array called just users. You will just push to that array the new user that you make without having to say user 5 here. Like we could just have. Let's see if I could come up with an example. Let's copy this. classes. Like I don't want to create another variable, user file, but I'm hiring a new person. So first I'm gonna change this. I'm just gonna have users. I'm gonna remove the map. So we have this, right? I want to add a new person. And I don't want to create another variable. What I could just do is do users dot push. And then here, I'll create my new user. New user, Alejo, ID 6025. And the thing that yes, Douglas?
No, it's okay. Actually, I have a question, but you finish your
Cool. So here, I didn't create another variable. And I was still able to add a new user to users if we console log this. Let me close this. Node classes.js. Oops. User is not defined. Oh, that makes sense. I didn't copy the constructor function. Let's try now. Right, so now I have my new user. The thing is, well, you could say, okay, then you have another one. You have another user that's coming in. Then you will need to add a new line to your program, right? And so on if new people come in. The thing is, what we could have is this be a function. Well, the constructor function is already a function, right? But imagine a function that asks the user for who's the new people that you want to add, right? And then it just adds it to the array without having to create a new variable. Like in the browser, I could show you an example. We haven't seen that yet, where I could ask the user, okay, give me the name of the new person and give me their ID. I'm just going to add it to the users array without having to create another variable. How does that feel? A little bit better? Cool. Do this?
Finding out that which eventually we will be getting basically user input. So but if there was a way for to be set up so that user ID could be a function that incrementally increases. So as you can see, it's just one after another. So that way you only input you put in his name, and you would just build a new instance for each, or a new, would incrementally increase that number for every instance under the starter function.
I really like that thinking, because that's what we want to do. We want to identify repetition and just get rid of it. In this case, what Douglas has mentioned is, oh, the IDs are incrementing by 1. The computer can do that. We don't have to take care of that. So we could have an ID that auto increments. We could write a function that does that. Okay, so this was how we were doing with constructor functions. Let's look at, we did that, and so is it clear why we would want to use constructor functions rather than just writing objects here like this? Right. Cool. Okay, so now in ES6 we get an easier or more elegant way of doing the same thing, and that thing is called classes. So a class, the same as a constructor function, is just a blueprint for an object. Blueprint, you could call it blueprint, you could call it template, definition. Yeah, you can define what an object is. But yeah, you could call this anywhere. It's like a model for an object. And then let's look at it like side by side. So this is how we were doing the constructor function. Let's look at it here. This is a constructor function. How many keys an object made out of this constructor function will have? Let's see. Alessandra, how many keys of an object made with this constructor function will have? One, what key would that be? Right, correct. That will be, Corey will have a key call name. Cool. Anything else that we want to comment on this constructor function? Maybe that you are looking at it, something that was not very clear yet for you. Malik? A little bit louder? When we are doing in the constructor function, and as we're going to see in classes, this is how we add a new key. And we want, a very common pattern is we want to, the constructor function will expect some arguments, in this case name, and we want to save that argument to the property of the same name, in this case, a property called name. Okay, so this is how we could create an animal that's going to be Corey. He, by the way, he was my instructor. He was one of my instructors. He was a JR's instructor as well. Now this is how we do it in a class. So let's take 3 minutes to for you to write this, write the two the same class in let's talk about classes in this. Let's write the same class in the two ways to do it, which is ES5 with a constructor function and ES6 with a class definition, and then create an instance of that object. And then see if they have the same keys. We might actually see something interesting as well. Yes, sir.
ES5 right?
Mm.
But I've never seen online
It's more the ES5, ES6 is more common. This is more like we have to know ES5 because we might work in code that is a few years old, and in that case, that code does not support classes. We have to go back to constructor function. Okay, what are some of the? Tell me what did you find? Did your code break? I think it should have broken for something. Should have. What did we find? Douglas?
That, at least for running so far, because animal is already declared as a constructor function above the class function,
Excellent. That's the.
It's throwing an error that says identifier animal.
Great. That is. You could have not described it better. If I try to run this, it says identifier animal has already been declared. So that is saying we have two things called animal, right? We have a constructor function and a class called animal. So we cannot have them called the same. So I'm gonna change this name to be animal class. But oftentimes you're like I'm only doing this here because we want to see the differences, or not the difference. What we want to see is if these two actually produce the same result. So I'm going to call it animal class, and then I'm going to do new animal class, Corey. Now, so note that I also have, if you did let Corey, just Corey and Corey here, you will also get the same error, which is identifier Corey has already been declared. So I just changed mine to Corey 2. And now I'm going to console log Corey and also console log Corey 2 to see. I'm going to run my code, and I have in the screen two objects. One was made with the animal constructor function. The other one was made with the animal class. They both have the same key name with the same value. So this is to kind of bring home the fact that this, again, are just two ways to do the same thing. We are creating an object with the name Corey. Okay, any questions here so far? We're gonna get into like the differences that we spot. So raise your hand and tell me one difference from the class definition from the constructor function definition. Yes, Joanne? So we change keywords, as Joanne said. Instead of function, we have class. I'm going to say function became class. I like that. Somebody else, another one. Cameron? Okay. So let's go with that one together as to now we have another keyword constructor and receives the parameter. So this is the way that we're doing here. This is a function, and it's good that you notice that constructor is a very special function. There can only be one in any class, and the constructor is a special name because this is the function that gets called once you use the new keyword with the name of the class to instantiate an object. So a constructor is the one that makes it, is the one that will actually create the object out of that template. Yes, ma'am.
So is constructor basically the same thing as
Yes. In that case is, so what Brianna said is this constructor basically the same as animal? And the answer is yes. So we could think about now here, this was a constructor function, right? And then this function, not by coincidence, is also called constructor. They produce the same result. Well, they're not the same because we have different keywords, but they produce the same result. They produce the same result. So Michael is saying, is a class bigger than a constructor function? The answer is no. I guess like it will depend on also your definition of bigger. If you mean like it occupies more space in memory, the answer is no. And then we're gonna see how this becomes easier for us to think about than having to do the ES5 version. Oftentimes in the ES, as we get new versions of JavaScript, what those versions allow us to do is just do the same thing in an easier way, in a more compact, easier on the developer way. So okay, so we have the class, we have the curly brackets that indicate where the class starts and where it ends. And inside we have one special function called constructor that is going to be the one that gets called once you instantiate an object like here with Corrigio. Okay, and the only other difference, as Brianna said, is that this constructor is not, it doesn't use the name of the class, it just uses the keyword constructor, but that this one will be basically the same as this one. Right? And then the parameter goes into the constructor. Cool. And we can see here that this might be weird. I mean, we have an animal class, right? And we're saying it's a class, but we're still using parentheses. And when do we use parentheses? With functions, right? When we want to call the function. But it's just that when we have animal class, parentheses, and the new keyword, what is going to be called is the constructor. So here, animal class will pass in Corey as the name to the constructor. Any questions here? Yes, Douglas.
Outside of what we're talking, I know that ES5 can be increased to all the ES5 stuff can. So that means, I guess, no matter where you stick the function, keyword, constructor, model, you can build an instance above or below. But for this, you can only make instances below that point go. Okay.
So raise your hand if you don't remember what hosting is. This is totally fine. I actually encourage you to. Okay, so everyone knows what hosting is. Okay, a few. Maybe who could explain it for us? Or just not explain it, just like talk about it. Yes, William, thank you.
For ES5, especially when you create a function, it automatically gets put up at the top. So like when you can call the function at the beginning of the code, even though you're going at a couple lines down.
Yes, exactly. That's what it means. Hoisting. Yes, Cameron.
We don't physically see what the top is not actually going to be. Or sort of.
That's
like visually.
So we don't see that function be moved at the top. That is something that JavaScript does automatically for us. But when we have ES5, this function I could call it here, for instance. I could do this. I'm calling the constructor function animal before I even said that an animal existed. This is all thanks to hosting in JavaScript. That is, a function definition like this will be moved at the top before we start executing our program. So we can imagine, like, under the hood, there is another program that it goes reading our code, and if it is a function, it will just take it out of there and put it at the top so that we can use it anywhere else. So what Douglas was saying, does that, or like the question was, does that still apply to classes? Can I say this? Right? Can I try to create an instance of the class before the class was defined? And the answer to that is given by JavaScript. Animal class is not defined. You see that even though I moved this one too, but it's not complaining about this one. It's not complaining that the animal constructor function is complaining about the animal class. So the answer is no. Class definitions don't get hoisted to the top. Only functions. Yes.
Specific reason, because when I was trying to use type of class in code versus its function.
When you do type of class, oh, that's a fun experiment. Let's look at that. So Vanilla is saying when he does type of class of animal class, he says this is function. So this is another hint for us to say this is just syntactical sugar. This is only for us, the developers of JavaScript, to have an easier way to utilize constructor functions. And then this here is animal class under the hood is still a constructor function, right? Still the same thing. Yes.
It's only is 5 functions that are hosted, and is 6.
Yes, only ES5 functions are hoisted. And here Bonil pointed out that, well, if we truly look at animal class, that's still a function. So there is no the introduction of like class syntax to JavaScript doesn't introduce a new type, right? We don't have a type called class that we say this is a class per se, or that JavaScript distinguishes between a class and a function. And here we found that JavaScript doesn't distinguish between a constructor function and a class. And again, that's just because class is just a more elegant way to declare a constructor function. Mm-hmm. Yes, Joey?
For ES5, it was necessary for us to capitalize the first letter of
Mm-hmm.
does that still hold for ES6?
That's a good point. We still want to follow that convention of having capital the first letter of our class. Yes, I believe it will still work if we have it lowercase. Still works. This is again just a convention in the JavaScript developers, and actually, honestly, like most other programming languages, still use a capital first letter for representing a class, or saying that an object was made out of a class, right? To signify that this is, I think, Stephanie, you were telling me yesterday, like that a class or a constructor function will be, we could think about it as a type of an object, right? We could say an object is an animal, is an instance of animal, like in this case. In this case, Corey is an instance of animal. So we could think about classes and constructor functions as a sort of a type of an object, right? We say that we could, well, this would not be technically correct language, but we could say Corey is an object of type animal, right? And again, this is not like technically correct, or maybe in that will not be the same as saying Corey is an instance of animal. Corey is an instance of animal is more precise language. But if it is useful for us, we can think of Corey as an object that is of like animal. Any other questions? Okay, so we have that, and then let's see. We saw that they produced the same result by console logging the two Corys. Let's see what else do we have here. Any other questions? Okay, we're gonna get there. So the next thing that we're going to see is we saw how we were able to. This is an animal class, and this animal class doesn't have any methods to it, right? It just has a property. And the way in which we could add a method to this animal constructor function was when we did animal that prototype that talk, for instance. Yes, Jar.
Actually, so earlier we were talking about how to create multiple instances of the class, okay? So like typing, or maybe not even class. I'll share the code on the 6.2 export to user root to create that instance. Take a look at every every time. They also answer.
Thank you. So here, let me ask you this. What do we use? So there was two ways in which we could add a method to an object, right? What are those two ways? Well, I kind of gave one away here, which is the prototype. What's the other way? I mean? Put it inside here. This is the eat. All animals eat. Let's do console.log. This name is. Okay. We cannot use the prototype now here. So this is one, and then this will be the other, right? Console.log. Blah, blah. So we have added two functions to the animal constructor function, right? So that means that all the objects that are made with the animal constructor function will receive those functions as well, right? So that means Corey now is able to talk. Oops. Let's see this. Let me comment this out. This is where in the ES5 constructor function for now. Let me see blah blah console log. So here we have Corey. We gave the animal class or the animal constructor function the ability to have a method that is called talks that all the objects made with that constructor function will inherit. Do we all agree in that? Now, yesterday we were talking about when would we, like what the differences were of declaring the method here versus declaring it in this prototype. And what was a point that I think I reiterated a few times yesterday about the prototype? What is the prototype and why would we want to put something in the prototype? Who remembers or can I speculate as to what the prototype is? Or why is it used for? Let's see, Peter?
The prototype, we want it to be the same for everything. We want it, we put it inside, we want it to put inside the actual.
What do you mean when you want everything to be the same? What's everything?
Code itself, not to.
Okay. Somebody can compliment Peter. Yes, Michael.
When you want the function to be a reference instead of part of the instance, when you call it, it's not. It's looking at the reference, not actually.
Okay.
You don't look at the animal prototype instead of coding.
Mm-hmm. That would be more a technically accurate description, but I'm kind of looking for a point in the middle where we could get as to why we will want to use the prototype. Yeah.
It allows favorite share.
Great. That is exactly the one I was looking for. We want to put a method in the prototype when we wanted the behavior that method represents to be shared across instances, to be so that every animal that I get out of the animal constructor function can share the talk method. And yes, sure.
We do the same thing by just adding it to the constructor.
Mm-hmm. So Char is saying, well, this is still this. All of them will get the same. All of them will get it, right? But then the thing is, like here, we're not sharing because here every single one gets its own copy. Every single object will get a different it. It's just that the it does the same thing, but every single animal has its own unique it. In this case, there's only one talk, and that talk is in the prototype, and all the objects share it. The example was like if we had a mic in the classroom, if we only had one mic, that mic will live in the prototype. Then if you want to use a mic, you have to come up here, and somebody else wants to come use the mic, they have to come here. There's one mic and it's shared. If we had that mic in here, it's as if all of us had our own microphone. Yes, Peter?
So if you wanted to use like this name prototype, you can.
This name in the prototype. Yeah, like you could, but do we remember that first when we do query.talk, JavaScript will first look in the properties to the object, and if it doesn't find it in the property, it looks in the prototype. So here, JavaScript will first look in the properties of the object. The object only has two properties, name and it. It doesn't find talk, but the next step that JavaScript does is go to the prototype and see if there is a talk in the prototype. In this case, it does find it. If you have name in the prototype, the same process still apply. JavaScript looks at name in the properties of the object. It finds it. It doesn't keep looking at the prototype. Yes, Alexander.
What if you put this .e inside
If I put this .it inside here, like if I do this,
yeah, like that, but then put this
You mean like now I have it in the prototype?
No, like you put like, like, you take away the constable, you put this dot E and then the
Like that?
yeah.
I think this might work, but it's sort of convoluted because it will actually it will not. It will never see. We will never run this program. Like I could do console log. This might be a little bit obscure, but this is never because this is never run. If I do query.it, you say query it, and then this is never run. This function is never run. This function lives in the prototype, right? So it's shared, but the instance has an it method. So again, when we have query.it, the first thing that JavaScript does is look in the instance, look if it has a property called it. If it doesn't have a property with that name, it looks in the prototype. But in this case, we do have a property it. It finds it, it calls that, it doesn't keep looking. Does that make sense?
So the prototype is very state memory.
Yes, and then, so that's like a good advantage of sharing behavior is that let's imagine this that it weighs the let's imagine like a random number. Let's do 2 kilobytes. Right, it was going to occupy 2 kilobytes in our memory. Right, if we have it in the instance and we have 1,000 animals, then that's 2,000 kilobytes. Right. And if we have 2 million, I don't know what that number will be, but it will be larger, right? So instead of having the it in the instance, because we know that the it method is share behavior that all of them can share. It doesn't uniquely apply to one. We can say the name applies uniquely to one, right? We want to be able to distinguish them, and the name will be unique. When we have common shared behavior, we put it in the prototype so that even if we have 1,000 animals, this it method will still occupy just 2 kilobytes. Yes.
Can you reassign that to the function to E or the top?
Yes, you can override it. Yes.
Let's say can you do it using? Can I do query that reassign that?
Yes. Mm-hmm.
Would I be able to reassign the top template?
So you will not be able to reassign talk. What you will do is you will create a talk in the instance. Now, when you try to call talk in the instance,
Using query.
it will find the one.
If I use like another object, then we go back to.
Mm-hmm. That's correct. Okay, so again, the prototype is a special key in the constructor function that we use to put functions that are going to be share behavior among the instances. Right? And here, we only want to put properties in the instance that are unique to that instance, to that object. Right? Like name, age, but if it's share behavior, like talking, all animals, well, not all animals still talking, but eating, then we could put that in the prototype and save some space. Joey?
All right, so maybe just make 10 animals. And with those 10 animals, we use that the constructor object the way that this key. That's one. Say we make another 10 animals, but without this seed, well, instead of this seed, we do a prototype E. Same thing. Those 10, that second group of 10 animals, that's the same exact thing for everything. I mean, everything,
all the behavior is the exact same thing. The only difference that you get is
easily, like just change the one prototype line.
yes.
Changes everyone.
Changes everyone. Yes.
That's the first group. Yeah.
That's correct. And then if you have 10 made with this version that you have the function inside, and 10 with the function in talk, then the 10 will occupy less. The 10 that have the function in the instance will occupy more space than the ones that have it in the prototype. Because the one in the prototype is shared, it's only one that gets shared among all of them. Does that make sense? Yes, sure.
Sometimes it gets popping, right?
Yes.
So it gets posted too.
Say that again.
It gets posted as well.
Prototype gets hoisted. Oh, this statement does not get hoisted now. If I try to do, let's get rid of this. If I try to do like Corey.talk here. Oh, well, Corey needs to be defined. But now I'm trying to talk, but with Corey, but then it says Corey.talk is not a function. So this is not hoisted. Any other questions here before we see how we write this in classes? Yes, Joey?
You said that you can't change what you did already. Is there any code?
No, I can't change it, yes.
Can
Mhm. It will be like, imagine like, back to the mic example, I have a black mic, and that lives in the prototype. If I want to now have a pink mic, I could just change it in the prototype, right? If all of you have one mic, then I have to, and I want mics to be pink, then I have to go on each one of you, change the color of your mics. Okay, so we'll see how classes make our life a little bit more enjoyable, and when we're programming. So this is what we need to do. We found that if we share behavior, we want it in the prototype and not in the instance. We only want in the instance stuff that applies uniquely to the instance, like a name. So let's do the same with a class. Let me change this back to that. I'm just going to call this animal2 instead of animal class. I don't like having that class part at the end. Okay, so how do we add? We want the class version to also have a talk, method, and we want that method to be shared across all the instances. We don't want it uniquely we don't want it to apply uniquely to the instance. What we want to do is just declare it here, talk, parentheses, console log. Isn't this easier than doing animal.prototype.talk function? Look at the difference. Yes?
Is it fixed?
What do you mean fixed?
Like into the actual
Oh, are you saying that because you don't see any like keywords accompanying talk? That is a good observation. So Cameron's saying, is talk a special keyword? Because there is no function, there is no let, there's no this. The answer is no. This talk is not a special keyword. This is how we could define a function inside a class that will be part of the prototype. We don't need to say it's a function. JavaScript will know that if it finds a name followed by parentheses, it's just going to interpret that as you want to create a function that is going to be added to the prototype. So you see how here we define this function, this one special one, constructor. You never say this is a function, right? because we're using this syntax, and we're inside class. JavaScript knows, oh, okay, you want to create a function and add it to the prototype. Jen? Say that a bit louder. Yes, if you could give me an example.
Just like use ES5, ES6.
So Joanne is asking, can you use ES5 constructor function and ES6 class definition? And the answer is yes. You could mix them. However, it's not recommended. You like, as I said, in general with ES6 and ES5, is not good to mix them. Right? You either write it all in ES5 or all in ES6. Only in very peculiar cases you want to share it. But also, I wanted to note that in that question, it depends also on where your program is going to run. If your program is running on like an older version of Node that doesn't know ES6, then that's a constraint. You cannot do classes because then your program will crash, right? If you have an older version of Node. Yes. Anybody else? Cool. So again, this is how we can define the same function that we were adding to the prototype in the constructor function. This is how we do it in the class. So now if I have animal2 should be able to do query2.talk. Right. Let's just make sure that this works. Blah, blah. We don't have any other query talks. No. Any questions, comments, emotions? This is how we can add a method to the prototype. I'm not going to demonstrate how we could add it to the instance because we saw that we don't want to have methods in the instance like this.talk, because then everyone will get an individual copy. And we saw that if it's shared behavior, we can reuse it, indeed share it. Okay, let's see what else we have here. Cool. So now we have something called, and this we didn't see the equivalent on ES5. I guess we could see it if, let's see. Could I introduce this? We have another keyword that we have in the class definition is static methods. And we're gonna need to be able to distinguish between a static method and a regular method. So here we have the talk method. This is an instance method, right? That was defined, is defined in the prototype, right? So a static method, let's look at some of the static methods that we have already been using. Maybe we haven't realized that they're static methods. So one of those is math.power JavaScript. So if we think about it, math here is telling us that there is somewhere a class or a constructor function that's called math. And so I could technically create a math object, right? I could do this. My math is going to be equal to new math. Oh, turns out that math is not a constructor. So, okay, so you cannot really create a math object. Math in this case will be, is not a class, is not a constructor function. In this case, we have that math is just a simple object. Let's look at if we do type of math object. We saw that when we did, we could do type of array. This is the array class or the array constructor function. We have function. Right, so we cannot do it with math. Let's go with array. So we can see, let's look at the array documentation in the end. We see that, we saw that in the documentation we have like array.prototype.concat, array.prototype.filter, and they are in the filter because, well, we want all arrays to get one, and we want to share the filter method, right? But then there are others like this array from, an array that is array. These methods are not in the prototype, right? If they were, then it will say array.prototype. So this is what is known as a static method. A static method is a method that exists in the class. It doesn't exist in the instance, right? Here we're going to have the array.prototype concat. All of them, all arrays have a concat. Concat lives in the prototype and therefore is available to the instance, right? Now, array that is array or array from are methods that are available in the constructor function. And in the class itself, they are not available in the instance. Let's look at an example of that. Let's see, let ARR 1, 2. We have an array. This array has a filter, right? Because we saw that filter lives in the prototype, right? We could also say, I also wanted to clarify, we will still say filter, even though it lives in the prototype. We could say filter is an instance method, or is available to the instance, right? The filter method doesn't live in the instance, it lives in the prototype. That's where it's defined, right? It's not directly in the instance. It's in the prototype, but we could still talk about it saying it's a method that is an instance method, right? Doesn't live in the instance, lives in the prototype, but we could still call it from the instance. But let's say, so I could do ARR dot for each, and the element, and then just console log that element. Right? All arrays have a for each, because for each is a prototype, and it's available to the instance, right? The instance here, the instance of array is ARR, right? Oops. It's available in the instance. And note that, well, another thing to note here is when we're creating an array in this way, we don't need to say new array. I don't know if do you remember that when we first saw arrays, we said there are two ways to create an array. One is just using the square brackets, and another one will be using the constructor function. New array 2. So there are two ways to create an array, and in this case, this is a shorthand, more concise way. But under the hood, JavaScript still utilizing the constructor function or the class. Okay, so we saw that, and then what I wanted to demonstrate is the fact that, okay, all arrays have filter. Now let's look if all arrays have something like isArray. First, let's see what isArray does. The array method determines whether the pass value is an array. So this is going to say array is array 1, 2, 3, and we pass in the array 1, 2, 3. It says true. Array that is array an object foo 1, 2, 3 false, string false, 1, 5 false. So we said that we can use this array to determine if a value is indeed an array, right? We cannot do that with type of, because if we do type of ARR, we get object, which might be confusing, right? But if we remember what I've been saying, like almost everything in JavaScript is an object, then indeed array is an object. So the way in which we could say, in the way in which we could find if we actually have an array is using this static method called array that is array, and then it's passing ARR half true. I try to pass in a boolean half false. So okay, so here this is what we call a static method. Method that is defined in the class or that is defined in the constructor function, and that is not available to the instance. Let's see what I mean by not available to the instance. So we saw that array ARR is an instance of array. Let me demonstrate that again. Instance of is the operator we can use to see if an object is an instance of a class or a constructor function. Array instance of the constructor function array, true. Right? If we try to say is a boolean instance of array, no. Nothing will be instance of array that is not an array. So we have ARR. Okay, so we said that ARR is an array. Now I'm saying array that is array is a static method. That means it's not available to the instance. That means I cannot say that is array and then passing an empty array. ARR is array is not a function. That is array again is a static method. It's only defined in the class or the constructor function and is not available to the instance. Yes, sure.
I don't see the point of making customized static.
You don't see the point of creating a customized static method. One valid point is these two examples on array, right? You don't want an array to be able to tell if it's an array. Like if you have an array 1, 2, 3, you don't want it to be able to say if it's an array. Well, in part it's because it's already an array, so it already kind of knows that that himself is an array, right?
Talking about the static functions inside the class.
Uh-huh. No, in this case,
For example, like static is example given.
yes, we're gonna get to that example. But in this case, JavaScript himself has a static method in array that is able to determine if it's an array. Static methods are designed not to be used in the instance. If they were in the instance, then that's where they will live, right? In the instance or the prototype. They are used for the stuff that is not, that doesn't need to be part of the instance, but that are still useful, like the ability to say if any value is an array. Another one of those is array from. So not all array, like no array that I create will have a dot from. They all have that filter, but they don't have that from, because that from is a static method. And then this one is method creates a new shallow copy array instance of an array-like or iterable object. This one is sort of more obscure, but just think that this again is a static method. We cannot say IRR my array dot from. Right? ARR dot from is that function. So the static method from lives in the class, is not available to the instance. Then we have this example in the lecture notes, which is we have a class point. It has a constructor. This is going to represent a point in a two-dimensional grid. Like, imagine this could be part of an application that shows you the stock market, right? And then you have X and Y points where you put the prices of your stock or the prices of the stock that you're trying to monitor. And then here we declare the static distance method, and we have again this special keyword here. The difference will be only the static keyword. And then the distance method takes in A and B. I will say A and B, and we can see here, for instance, what these two are. So we have point distance, and then we're passing P1 and P2. P1, we see that is an instance of point. P2 is also an instance of point. And then here, what static distance is doing is just calculating the distance between point A and point B, two objects that have X and Y coordinates. Again, this is like the same rationale. We don't want a point, like we don't want P1 doesn't need to be able to calculate the distance between 2 points, because it itself is 1 point, right? Instead, that kind of behavior, we put a static in the class so that we could, if we want to use it, we just do point that distance with referring to the class. Note that here, this point, this is the name of the class. This is not the name of an instance, right? P1 and P2 are instances. P1 and P2 are instances, but point is the class itself. So we use static methods for utilitarian functions, right? Like array that is array. There are not concerned with instances or with values of the instances like X and Y in this case, that they don't need to access the instance, and that are just handy to have for common tasks like calculating the distance between 2 points. Any questions here? Yes. Sure. But we're still like, yes, so what Shara is saying, could we just have a function that is able to do that outside of the class? The answer is yes, we could. But we're losing, if we do that, we lose the sort of the relationship that we have if we put it in the method, which is say, okay, point should not only be able to create a point, but also offer utilitarian functions that belong to points, like calculating the distance. If we have a function just called distance, then we kind of lose that relationship saying, okay, this distance is able to calculate the distance between points. Does that make sense? I think I saw another hand here.
Yeah, no, I was just gonna say, like the point of it just where it's whatever.
Yes, utilitarian behavior for related to whatever class it belongs to. So let's try to add one to our, what will be, I actually haven't planned this, but what would be a good utilitarian method for, or static method for our animal? Well, we saw that is array is array that is array. So we could have a static method that is able to tell if the value that was passed in is an animal, right? And that will be, we don't want like that behavior. We don't want that to be shared across instances. We just want to. It's an utilitarian function, right? We want it to have it as a static method. So let's do static is animal. Like Corey doesn't need to know that if he's an animal, right? He already, like, he's an animal. It's like you don't need to know that you're a human, right? You know that you're a human. But then it might be, if you have a large application, you want to be able to tell when I'm looking at what it is, right? We saw that we couldn't look at, we can no longer, or in this context of classes and constructor functions, rely on type of, because type of will always give us either an object or a function. But we want to see if this is if an object made of the animal class is indeed an animal, or any other value that we pass in is an animal. So let's try to do, how could we do this? How could we check if, so what I want to do is this. What I want to do is say animal2 is animal. And then I pass Corey. This should give me true. If I pass in an array, false. Even if I pass in an object that looks like Corey, false. Just basically the same that we have in isArray. It's related to the class. It's handy to have it, but we don't want every instance to have it. We just want it to have one in the class. So a way in which we could do that is, so here we just have value. And then a simple way in which we could do that is just return is value instance of animal2. So we saw that 45. Thank you. So we saw that if I have an array, I could say is instance of array. Is this array that I'm creating here with square brackets an instance of the constructor function or class array? Oops. True. Even though this array was not created saying new array, under the hood, JavaScript did that for us. Right, so we could have, if I have my, before we run this, well, so this is, let's not run this yet. I could verify if Corey is an instance of animal2 if I do so.log Corey2 instance of animal2. Node classes true, right? We can use instance of to verify if a class, no, if an instance, if an object was made out of a constructor function, of a specific constructor function. So if I try to do, was the value true created with the animal2 constructor function? No. Nothing that was not created with an animal2 will ever give you true. So the only thing that I'm doing is, it's kind of handy to be able to tell if something was created with the class that we're talking about here, which is animal2. So for that, I created this static method, is animal. That will return true or false whether value that I pass in here is an animal or not. Yes, Alexander. Static just means that it's a method that is going to live in the class itself and that is not going to be shared across instances. That's what it means. And I don't know if, yes, Peter?
Is the relationship between static and class like relationship of the type and function?
No, it's not the same. And I think like this is one of the fears that I had. The thing is that we didn't see how to create a static method with the prototype, but I could show you here. The same way will be animal that is animal. Here, I defined, now that we have this new acquired language, a static method in the animal constructor function. This is animal, will not be shared across instances. It doesn't live in the instance, it doesn't live in the prototype. It lives in the animal constructor function itself. So for using it, so this is what we're doing here. This just animal, not in the prototype, not in the instance, rather just in the constructor function. When we're doing in classes with static keyword, we use it in this fashion. Animal that is animal, and then I'm verifying if Corey2 is an animal. But I also want to verify if anything else is an animal. So let's see what we have here. Oh, I'll need to console log all of this. Console. Here, I found that it was handy to have something. If the developers of if the people that make JavaScript thought it was handy to have a function that is called array that is array, then I also think that it's handy to have a function called animal is animal to verify if an object or anything else, if any value was made with the animal constructor. So I'm going to test that if I do node classes, true, false, and false. And note here that I'm not calling Corey that is animal. I'm just calling the animal class itself. I'm using capital N, capital A here. I'm calling that constructor function. Look at what happens if I try to do Corey2 that is animal. Oops, big error. Corey2 is animal is not a function. Another way to say this is static methods are not inherited. Even though this method is in the class, the same way talk is in the class, talk will get put in the prototype. Static is just put in the animal to itself, in the class itself. It is not passed to the prototype nor the instance. And kind of going back to what Alexandra's question was, let's look at the keywords. Let's look at the formal definition of static. Oh, let's do the static here. Static JavaScript. At the end, the static keyword defines the static method for a class. Statics aren't called on instances of the class. Instead, they're called on the class itself. They are often utility functions, such as functions to create or clone objects. It's funny, I hadn't looked up the definition, but it's funny that we use the same one, utility. Yeah, that's what it is, utility functions, utilitarian functions. I didn't think about cloning. Cloning, that would be a good utilitarian function, right? If I want to have a clone of Corey, right? That cloning doesn't need to be in the instance, right? I don't want, I guess like you can imagine, you don't want Corey to clone itself. Imagine if Corey was evil. Then that would be bad. So, okay, so static methods. Utilitarian functions for whenever you want to do something handy that belongs to the domain of animals, but they don't need to live in the instance. Yes, Cameron?
Static methods have the same as constructor as the
Say that one more time.
So what I can't think of one more. Like you don't take name, right? You just have the same.
No, there's actually, that restriction doesn't exist. I could hear he say like gender. Oh, there are some. No, we could the same way. Oh, there's only one constructor. The arguments that constructor receive can be a large number of arguments. The way we were creating, we were creating dogs yesterday, right? And we had a dog that was initialized with the name and the breed. Same thing here. We could do gender. What happens here? Here's the question. I have animal, the constructor to animal is expecting name and gender. I'm only giving it a name. What is the gender of Corey going to be? Douglas? Undefined. When we don't pass explicit value, we get undefined by default. Let's console our Corey here. Oops, let's remove this. And comment all this. Corey, gender undefined. What do you call those animals that are like both genders at the same time? I think I heard it there. Hermaphrodites? I don't know that word. Oh, Aphrodites. Is it Aphrodites? That's something else. Yeah, there are some fish that are How do you pronounce it? Hermaphrodite?
Yeah.
Okay,
Close enough.
cool. Okay, so we saw constructor, we saw static. What else are we missing here? Inheritance. Let's talk about inheritance. So, okay, so I'm gonna get rid of the ES5. We're moving to classes. Or I guess I'm just gonna comment it out. I'm gonna call this just animal. Remove that too. We define a couple of functions in there. This passing to have a gender. Now let's think about inheritance. So inheritance in JavaScript is a mechanism that allows to express hierarchy, right? And again, model more closely the real world. So that we could say, well, Corey is an animal, but Corey is also a human. How could we express that in our programs, right? Because, well, this is like, we could say, we're expressing Corey, the idea of a Corey here, but we're not fully, still kind of missing something, right? We're unable to tell if Corey is a human or what species he is from, right? So what we could have is another class called human. Class human. But now I know in real life, all humans are also animals, right? They inherit some property. In real life, humans inherit some properties of animals, right? All animals need to eat. All animals have weight or weigh. Yeah. What else? Another property. Say that again. They drink water. They need water. They have a date of birth, right? All animals have a date of birth. Humans are aware of that. Others are not. Stuff like that. So now we want to say, okay, this class is going to represent a human, but we already have something that represents an animal. So in that case, we use the other keyword, extends animal, so that a human gets everything that an animal has, right? That's the case in real life. It is also useful to represent that in our programs. Okay, so we have an animal class takes in a name and a gender, and we could have it. Let's make it a little bit more real. So not all animals can talk. So let's change this from talking to sleep. I think all animals sleep. They do that, yeah. Let's do this dot name is sleep. Okay, so all animals sleep. So we're saying, okay, we want to represent a human, and that human should also have everything that an animal has, which is, in this case, a name, a gender, and the ability to sleep. For doing that, we do human, class human extends animal. We're extending the class animal. Okay, so as all classes, we have a constructor function. We need the parentheses, and here we want the arguments to that constructor. That's what we're going to pass in here. I'm thinking about what those will be. Animal. What is the property unique from a human that doesn't have an animal? Language, spoken language. I like that one. Maybe another one, so that we have two. Yes. Will. That one is kind of philosophical, isn't it? Well, I guess like that could be kind of language, but something more mundane. Yes. Favorite movie? Yeah. That is pretty mundane. Favorite movie. Okay, so we are going to have a human that has spoken language and a favorite movie. Now, we need to say, okay, this human is going to have a spoken language and a favorite movie. And because this class stands from animal, I also need to initialize those properties. I need to initialize the properties of animal, which is name and gender, right? If we leave it like this, let's see what we have. This, that, spoken language is equal to the spoken language. This, that, favorite movie equal favorite movie. Now let's create a human. Now Corey has upgraded himself, or we have upgraded Corey. Now he's going to be a human. Now here, the constructor function is expecting a spoken language and a favorite movie. So I'm not going to pass a name because, again, the constructor function of the human class is expecting a spoken language. I'm going to just do en for English. Let's just do it. And a favorite movie. Which one? Jurassic Park. Jurassic. That's not well spelled. Let's see. Jurassic Park. Cool. Okay, now we said, oh, I think this is going to break, but let's see it break. We're saying we have a human that extends animal. Let's see if we leave it like that. We have a constructor, spoken language, and a favorite movie. But we also, again, we also want Corey to have a name and a gender. Currently, it doesn't. But let's see what we have here. Let me clear this. Classes, and we have our program broken. Now it says the spoken language. Okay, it's line 43, and then it says reference error. Must call super constructor in derived class before accessing this or returning from derived constructor. Okay, that's kind of a little bit cryptic. It's saying I must call super, you know what that is, constructor in the derived class before accessing this. Okay, let's look at. So it's saying I must call super. So super looks like a function because when you call stuff, you're oftentimes talking about functions. And indeed, we have a function that's called super. And saying I must call that before I can say this, that spoken language. Right? We don't know what super does yet, but let's just let's see for now. I'm just calling this that. Okay, now I didn't break, and now I have my human. Has name undefined, gender undefined, spoken language English, favorite movie Jurassic Park. Right. So we have name undefined and gender undefined. And indeed, we never say Corey here. We never say, I want this human to be named Corey. Right? Okay, so what can we do? One is we will need to pass to the constructor, we will need to pass in name and gender as well. And I put those first. I'm going to pass name and gender to the constructor so that I could call Corey. Name. Let's see if that did anything differently. Now I'm passing in a name and a gender, spoken language, and a favorite movie. Oh no, still don't have anything. Still undefined. So let's look at what super does. If it was complaining that I must call it, it must be important. Let's go. I think I did include this one here. Super. Oops. Oh, did I might have attached the wrong link. I think I attached the wrong link. So let's do super JavaScript. Super. The super keyword is used to access and call functions on an object parent. Super prop, super expression. Ooh, look at this one. Super arguments calls the parent constructor. So this super function will call the parent constructor. When using a constructor, the super keyword appears alone and must be used before this keyword is used. The super keyword can also call functions on the parent object. Okay? So the main point here is that it calls the parent constructor. What's the parent constructor? What's the parent class of animal, of human? Animal, right? Human is extending from animal. So we could say human is sort of a child in those terminology of the animal, right? So he's saying super will call the constructor in animal. So it will invoke this constructor. So that means that if we want our query to have a name and a gender, we must pass it here because this is calling the constructor calls animal parent. Yes, we are using those two constructors as Shara said. We are using the constructor for the human class, and we're calling the constructor for the animal class by saying super. It's also known, animals is also known as the super class of human. That's where the name comes from. Super calls the constructor in the parent class. Let's see what we have now. Nice. Now Corey has a name and a gender, spoken language, and a favorite movie. So Cameron, this was what I was saying about like if we could have a class department in our company application that keeps track of the employees that we have, and then we have another class. That will be the first one. We'll have another class like employee, and we could have. I'm trying to think if this makes sense. Does like maybe the employee class would extend the department class, but I think it wouldn't in this case. So that's a bad example because a department, like a company department and an employee, they're two different things, right? In here we're talking about an animal and a human, where a human is a subset of the animal. Yes, sorry.
You want example, maybe it's like machine and like automobile machine.
Correct. That's a good one. Machine, automobile, machine, helicopter. And the most common one is the one that we have built in JavaScript, which is object. We have the object constructor function or the object class, and then we have the array class. And if we let's see if I can find an image. Constructor hierarchy in JavaScript. Let's see if I have an image. Oh no. No, this is a good example, but this one is not this one is not exactly the one that I'm looking for, but this is a good example for us. We could have an employee class, and then we have a manager class. Manager is still an employee, and then we have a worker B, or a regular employee, and then that employee can have, we have another class that represents a salesperson, and another one that represents an engineer, right? So this is what classes allow us to do, like represent these hierarchies. Let's see. I wanted to show you like the JavaScript hierarchy, which is in JavaScript, we have the topmost class in this example. Instead of employee in JavaScript is object. And then from object we have arrays, we have functions, we have, which one is another one? Strings, we have all those others. And then I think we only have just those two levels, like, but everything derives from object. That's what I mean when almost everything is an object. Only primitives are not, like true or false. Those are not objects. But an array is an object. Okay, so does this make sense so far? Cool. Any questions? Yes, Janesh. I couldn't really hear you. A little bit louder. In the constructor, it works either with a comma or a semicolon. You mean here? It works like this as well? Inside, I'm not sure.
This is not name, have to name.
Like this?
No, have to just the name.
Oh, like this? I see. Like this. No?
The right side is the equal sign. All the way here, the semicolon is replacing the comma.
Oh. I think it's just interpreting them as, it will be, this should still work then. Yeah, I'm not sure as the technical reason why it works. Yes. Oh, maybe in that case it will break if you use the strict mode. Not sure. If we separate them, yeah, then it says it's unexpected token, this. And this is because, well, JavaScript doesn't know if this is only one statement or multiple statements. In this case, what we want is multiple statements. So we could have this. Any other questions, Peter?
Can you scroll back down to the extends part?
Yes, here.
Now, if you already have like a variable for Corey the animal, is there a way to call it inside the human without just retyping everything? Retyping all the arguments?
You need to give me an example. Oh, like without retyping this?
Yeah, like instead of typing that, you just, I meant more like the variable like 42 or 49. Instead of just retyping his name and his gender, there would just pull back a previous element, a previous variable you created for Corey the animal.
I'm not sure if I understand the question correctly, but you want to get rid of this. Like you want to be able to somehow still create an animal or a human query that not pass the name or the gender to the animal constructor, but to the human constructor.
Yeah, like replace it with a variable. If you went up and we were just working on before we had the human part. Like under before you had let Corey equal and then information for the class and animal for Corey.
Wait, what line?
So you had deleted it, but
you mean like, I'm not sure exactly, like if I do here name? No, I don't think this is what you mean.
No. If you were to do like let Corey equal new animal and then his name and his gender, Could you then use Corey inside the human?
Oh, like
Does that make sense?
if I create first a query the animal and then I query the human.
Right, exactly. Can you do that?
No.
No.
Yeah. um, yeah, that'll look weird. I think because then it will be just an animal. It won't be a human. Like once it's an animal itself, it cannot become a human. We have to create the animal through the human. Right? And then the thing is like the constructor calls the parent constructor. So we indeed need to have we need to have this query call. So let's demonstrate also the fact that because Corey is a human, Corey is also an animal, Corey can sleep, even though like the human class doesn't have a function called sleep. Let's do Corey.sleep. Ooh, undefined is sleeping. That's interesting. Oh. Mm-hmm. Corey is sleeping. So can we see here how the human, because is extending of animal, is inheriting everything that an animal has, and the human class doesn't have a function called sleep. Only the animal has that. But because Corey, besides being a human, or because he's a human, he's also an animal, he inherits everything from animal, and animal has sleep. I mean, this one is better. You're saying like if I do, I'm actually not sure what you mean, like getting it with super. Oh, I see. Yes, I'm sorry. This is my mistake. This is what you're seeing. This is what you mean, right? Yes. This is better. This is better. Yes. Joy.
Instead of say he inherits same name as 41, but if you do instead of 40 string, put 40 dot name.
Yes. Mm-hmm. I feel like that's somewhat of a contrived use case, but yeah, I mean that wouldn't be. I guess like there's not a lot of instances where you actually want to do that. Mm-hmm. Let's just call this Corey because now we only have one. So Corey is sleeping. Yes, Cameron.
So if I wanted to make something new, like the miners, we wouldn't want to make it an animal or like separate. So child
Mm-hmm.
instead.
If you want to make like a lion,
Yeah, but I'm not going to that lion animal, blah, blah, blah.
mm-hmm.
But to make a whole new human type.
Well, yes, you will make another class called lion, or yes, and then I think like it also depends on the level of description that you want to use in your program. Like my program could be okay with just animals, right? But if I want more specific, I don't know if that's a word that I can pronounce, specificity. If I want more specificity, I'll want to have a class human and another class lion. If those two things are meaningful in my program, That makes sense? Like it's up to you, basically, the developer, or the requirements of the project as to how detailed you need to describe something. Yes, Douglas?
I think that it won't work in the opposite direction. Build a function in like hamburger. An animal won't be able to eat a hamburger.
Great. Let's try that. So Douglas is saying it will probably not work the other way around, which is if I have a method in human, then I would not be able to call that method on animal. So let's do a method on human. What would be a good method for a human only? I would say dogs walk. Earn money, go to work. Let's earn money is better. And for now, like our methods are very simple. They're just console logging. Like we'll want earn money could have something like imagine in human. We also have another property like how many like bank or money. Just like let's just call it money. For let's say all humans are born broke. So a human money is 0, right? Let's now make earn money do rather than just console logging. Let's actually increase money. This that money plus plus. Let's do this that name earned money. Now earn money. Now he or she has you mean like they earn this amount of money? But in this case, they'll always earn like $1. Let's do it. Let's try it this way. Let's see. So earn money is a method that we define in the human. Now we have another variable that is money, and it starts at 0. Like note also a couple of things. One is we have established that all humans are born broke, so I don't want to pass in here money, right? Because then that'll be. I mean, I could, but because this is my own world, the one that I'm creating here. But let's just assume, like, what I want to draw your attention to the fact that you don't need to create keys in this object for every argument you pass, right? Yes, you could use the default. So here is just like we have established that money is not something that comes from outside. That's another thing that kind of you have to make the money, right? It's not that it's just given to you. Okay, so earn money is a function that lives in the human class, and it's just going to increment money, and it's going to say this that name earn money. Now he or she has that amount of money. So let's have Corey make some money. Earn money. Let's make it have few. Now he has 3. Now I guess like Corey. Actually, instead of console logging here, I could just do console log earn the money and then console log Corey dot money. Right? So how many dollars is Corey going to have? 3, right? Because we're increasing by 1. Now let's see. Corey is sleeping, then 3. Corey made $3. If we have it like this, this could still work. Just the console login side, but Corey earned money. Now she has 1, 2, 3. Cool. So now earn money is a method. It's a human method, right? Not all animals can earn money, and in this case, that still holds here because again, earn money is a method that only exists in human. So I'm gonna create another animal. Dog, new animal. This is going to be a Pluto. Gender. Oh, let's have. What's a female dog name? Do we have? Okay, that's true. Let's go for Pluto. Male. Okay. Now we have the dog. Now let's try to see if the dog can make money. What do we think? What are we going to get? Error? Thumbs up if you think we're going to get error. Okay. Now thumbs up if you're saying we're going to get undefined. Okay. And then thumbs up if you think we are going to, the dog is actually going to make money. Cool. That's it. Error. So the majority were right. Dog that earn money is not a function. Right? Does this make sense? Dog, dog, which is an instance of animal. Does animal have a make money or earn money method? No. Right? Only humans. So this is what you were talking about. It was that a human can call a method from the parent class, like sleep in this case, but not the other way around. An animal cannot call a method from the human class. Mm-hmm. Yes.
So if you went one further, like class taxi driver extends, and then add that you would have both the functions of sleep and earn money.
That's correct. I could go further down and create another class that's a taxi driver. That taxi driver will extend from human. And as that one will be interesting in the sense that we can say class taxi driver extends from human, and that's it. We don't need to say class taxi driver extends from human and extends from animal. We don't need to say that because, well, human already extends from animal. No, you cannot extend from multiple classes. Like, well, yes.
But like, if animal extend into something else, then doesn't human technically extend into like a third thing?
Not necessarily. Like, let's have animal and then just have another class, mammal, for instance. We have animal, mammal, and then human.
No, there was something higher than that.
Higher than animal? Oh, so if there's something higher than animal?
An animal extended into that thing.
Yes.
Human extended into animal. Human extended into that third thing.
That's correct. That's like, that will be like, let's say there's a higher order class called being, right? Not all beings are animals. And that depends on your upbringing. But then by default, if we have animal extends from being, and then human extends from animal, therefore a human will inherit everything from the being as well. Sorry.
That means how to deal with the super.
In that case, that case is no different from the case that Douglas mentioned, which is the taxi driver. Yes, Jonathan? Okay. That will be like, well, Corey is a guitar player, so I'm going to create another class called guitar player. Oops. What am I missing here? Raise your hand. Yes, I'm missing that too. Thank you. Janesh? Extends. Okay, yeah, like help me write this. Extends. Extends from where? Or from what? Sihan, what do you think? Whatever you think like this should extend from. In here we extended from animal. Human extends from animal. Now when I represent a guitar player, which one should it extend from? Animal or human? Human, right? No other animal plays the guitar or is a guitar player. Okay? Okay, what do we put inside? Somebody else. Stephanie. What do we put inside the class? What's the first thing that we put inside? Correct. Create a constructor. Constructor. Let's see. Constructor songs. Either player has some songs. Oh yeah, mastery level. Great. This is a good example. Now we have. So now this is to Sergio's question. How do we deal with? Now we have 3 classes. So now we have a guitar player that extends from human, and human extends from animal. Therefore, we could say that every guitar player is also an animal, right? So Sergio is asking, how do we deal with the constructor, like with the super? We still have only one super, and here we want to pass in what the parent class needed. The parent class needed name, gender, spoken language, and favorite movie. So here, I'm just going to use name, gender, spoken language. Oops. Favorite movie. Yeah. But I also need to include them here. Now my list is growing. Name, gender, spoken language. This order, by the way, doesn't matter. Favorite movie. When we have something like as long as this, a convention that we have in JavaScript, spoken language. When this is getting that long, what we do is we just break it down into multiple lines, but it still will be the same thing. We just break it down like that, but it's still the same thing. This and this, still the same thing. Yes, Cameron? So, because how can super call the grandparent? That's kind of the question, right? The answer is Well, we can see that this is the super is going to call the parent, right? Now let's look at the parent. It's going to call the parent constructor, right? So super calls the parent constructors, which is this one. And the parent constructor is calling its own parent constructor, therefore the grandparent. And that's how it gets initialized, the grandparent. So you, how does this feel? We have the super calls the parent constructor, and the parent constructor calls the grandparent constructor, right? Yes.
But you said you can't like tree it out. So like you can't have multiple jobs under you. You can only go straight in.
What do you mean? No, I could still have, if by that you mean that I couldn't have a taxi driver, I could still have a taxi driver.
Branched off of you.
Yes, now I have like human here, and then taxi driver and guitar player.
Oh, I just heard.
Uh-huh.
Okay, I mean, it's set up the same way. I call that same super human. So
I guess kind of going back to what Michael was saying, then what happens if you have a taxi driver that is also a guitar player? Right, that will be like what you were saying. Like, can you inherit from two classes? Yeah, we'll need to look at that more in depth at a later time. Any other questions here? So this is how we could get to the guitar player. Let's see what else are we doing here. Inheritance, resource. Right, so that is pretty much the content. Any questions? Anything that you want to revisit in here? This is the time. Yeah, sure.
Pretty much super is pretty much calling the parent constructor.
That's it. Current super calls the parent constructor. You could also do other stuff that I haven't seen used a lot. But you could also do, I think I saw some examples here. No, I'm not finding it. Like if you wanted to call a function in the parent, you could do super function on parent. Mm-hmm. No. What you will do is, if like in that example, if we have a taxi driver that is also a guitar player, what we could do is kind of have right, not even combine, have another class that is able to represent both. Like, let's find something common between a taxi driver and a guitar player. Well, we already have something in common, which is the human, right? Moneymaker, right? Or yeah, I'm not sure exactly what, but in that case, then we could, if we want to represent a guitar player that is also a taxi driver, then we could switch the relationship and say, okay, we're just gonna have a human, but now that human is going to have a key call job, or what's another, like career, or something like occupation, right? And then we have the human that we're able to represent the guitar player and a taxi driver. So, okay. Any other questions? Yes.
If we have a moment, should we use static?
Sure. So we have here, let's see. We saw that animal has a static method. And we want static methods to be utilitarian functions. Functions that are related to the subject matter, which in this case is animals, but that do not need to be in the instance. This function lives in the class itself, doesn't live in the instance, doesn't live in the prototype, and it utilitarian functions, like each animal. The ability to say if something is an animal. I believe this is something that I didn't verify. I believe because all the other classes, human, well, I removed guitar player, but human extends from animal. I think all the humans should also be able to call, say if another, no, not all the humans, but we could also do this. Is Corey, no, not Corey, the class animal is animal. Oh. Oops. Yes, thank you. So now Corey is a human, right? But Corey is still an animal because all animals or humans are animals. So this should still work. Oh, dog cannot make money. I think I didn't console log it. Right. Corey is an instance of human, but because human extends from animal, then Corey is also an animal. Right? That means that Corey is also an animal. And again, here, like, we don't need all the humans to have a function called is animal. Right? We don't need all the dogs or all the other animals to have a function called is animal. That is a function that we can define in the class. Is utilitarian. Not all the objects that are made out of that class needs it. And then therefore we say that is static method, and we use it in this fashion. You see that this is not the instance. This is the name of the class. Corey here is an instance of human. But here we're only referring to the class itself. Yes, do this one more time.
I don't know if, why you need to, but can static instances be overridden? So like if we needed to like make sure that humans are an instance of humans, is that possible, or would it always still return animal on an instance of? Well, actually, no. I take that back. I think I finished my question. So if you put animal dot is animal, and then if you did human dot, and then you made a static is human, you would still be true.
That's correct. Yes. I mean. Oh, that one is a good one. Human that is animal. Let's try. Human doesn't have an is animal, but I think because human extends from animal, then humans should get everything from animal, so this should work. Well, let's see. Can the human still ask the question if we have an animal? Yes, we can. This is again another demonstration that human inherited everything from animal, including its static methods. Yes. I cannot do object that is array because object is the parent from array. I think I saw somebody on the table at the back. Yes, Owen. Oh, I removed that, but yeah, I can write it. Oh, okay, cool. Thank you. Cool. So let's take 7 minutes to stretch, get some water, go to the bathroom. After that, we're gonna be doing the exit ticket. Yeah. we're gonna be doing the exit ticket. So stretch, grab some water.
No, that's. All my friends are learning to go their speed.
So basically, since we're changing the date for the Hangman project, should we let people know that they're gonna be working with this? Because like, I feel like some people actually like wanted to work on the Hangman and stuff. So maybe like let them know that there's like a change of a plan. So this is gonna be like an actual class project instead of side project. And then, but still gonna have like the same price and all that.
Okay. All right. So then. Okay. So like everyone gets into the
Right.
competition.
Right.
Like, we're still gonna award this the best one.
Yeah. So instead of like tic-tac-toe, we're gonna change it to Hangman, and then we're gonna work on that.
Oh, this one.
Yeah. When should we make that due then, basically? If you,
The due date for that one.
yeah, for the Hangman.
You had the Hangman originally for like after.
Like at 9. Like
Right.
that was a deadline for the Hangman, and then like if we could actually have like a little like presentation or something like everybody gets 3 minutes to 2 minutes to present it.
That would be cool. Yeah. Let's see, but
Because what comes on 10?
10 is HTML.
The intro to it, right? And that's like Saturday, so we're gonna have.
That's like most of the day because it's actually recovering it quite a lot.
Okay.
But wait, so the due date. Do we want the due date to be like 10? We could have.
So due date to be 10th, and we do like presentation and stuff on the Sunday, maybe.
Yeah.
You think that's gonna work? Okay.
I think that would work.
So officially, they will get Saturday to work on the Hangman project, and the due date is gonna be 10th. Okay.
Okay. So
You wanna announce it actually after?
Yeah.
Example?
So this is kind of cool.
Yeah, just like explain them like, okay, so tic-tac-toe, we realize that time is a little too short, but we also want people to like work on actual like terminal like JavaScript coding. So we're changing that into like we're turning Hangman project into like the whole class project. We're gonna work on that. Yeah, I'll let you.
Cool. Thank you. Also, so you're gonna be working on like the repo for that with the instructions, or
For the Hangman?
Yeah.
I thought Ben was working on that now.
Oh, okay. I'm not sure. Let's see. Let's see in the assignment. Because he has been putting everything here. Favorite for. Okay, yeah. He's
Ben is
gonna
working on that. So.
Cool. Okay. So, thank you for being back on time. What we're going to be working on now is please take the exit ticket. After the exit ticket is done, we could get started on the classes lab. We're also going to be working in the lab tomorrow. But actually, let me just verify. Yes, we're going to be working in the lab tomorrow when we come here. But yeah, if you feel like you want to get started, please jump in. Right now, please do the exit ticket. And also, there is, if I could have your attention for a couple of minutes before you actually start the exit ticket, or just like stop for a second. We're going to have, initially, we were planning on having you do a tic-tac-toe game on Saturday. But we realized that the tic-tac-toe, we're kind of short in time, and the tic-tac-toe game is challenging, and it's like really hard to have it in just one day. So what we're going to do is we're going to have, instead of the tic-tac-toe project, we're going to be building a project that some of you are already building, which is a hangman game in the terminal. And the purpose of this is for you to exercise all the concepts that we have been seeing, like function, classes, arrays. Those of you that already started, because this was a side project that, thanks to ER, we had introduced, you could just work on, we would expect more from you in what that game displays. So we're going to be working on that on Saturday. As JR informed me, the prices are still on the table, but this is also more than the incentive of the price is to exercise the concepts that we've been learning. So yeah. Yes, Ariel?
Is tic-tac-toe completely gone?
Tic-tac-toe is gone.
Okay, then it's still the goal you guys had, and still the challenge.
Correct.
Is the challenge date the same? Like August 9th?
The due date will be, yes, we could do August 9 at midnight.
Okay.
Mhm.
We're gonna, Saturday, we want to do the challenge too.
One more time?
So we're working on Saturday, but if we're getting anything extra, it's still August 9th.
Yes. And then on the 11th, we're gonna have like a small demo where you can get to demo your game before your peers. Yes, Jar, do you want to add anything?
Yeah, so I think he mentioned pretty much everything. So yeah, we're gonna have like a demo down the next. We're gonna have like 2 to 3 minutes like to go over what they made and like demonstration of how people will play. Also like one of the special things about the game we made. And, we also, I think you mentioned it too, but the price is still on the line. So we're still gonna have like awards ceremony prizes that we mentioned already. So yeah, just stay tuned and try to work your best. Try to be innovative. Try to create something cool. And yeah, you can show everybody the class.
I just want to, yeah.
Other thing is, so for the tic-tac-toe game, if you have a extra time that you're done with the hangman, you can still work with the game and you like submit it, like send it to us. And so think it as like an extra further basically. Tic-tac-toe. Whereas hangman is going to be your main side challenge.
Also, all of these, like, this can be part of your portfolio, or you can put it on your website of fun stuff that you've made. Also, I wanted to say that, like, what we're looking for in a hangman, like, I guess you could create your own version of the hangman, right? Be creative. It doesn't have to be just person hanging from a rope, right? This is up to you. Like, this is the concept of kind of guessing a word, right? Cool. So that's it. Get to work on the exit ticket. If you have any questions, we're going to be floating around. Again, the exit tickets are individual, closed book, and we can start working in the lab. Thank you. Yes, Joy?
What format is the hangman supposed to be in? JS file?
So yes, a JS file that we run in the terminal with Node. We're currently working on a repo that has the instructions, and how it Yep. Say that again. You can start on the lab, structure lab.
Yeah, you get up to get ready. It's like when you like get tired of start laying down. Yeah, this is